wave optics. In 1637, Descartes proposed Newton's corpuscular theory. Descartes proposed corpuscular theory. It is called Newton's corpuscular theory because Newton developed it after it was proposed by Descartes. Then, the principles of corpuscular theory. Light is considered as it is made up of tiny particles. Light is considered as it is made up of tiny particles called corpuscles. Corpuscles are elastic, rigid, and weightless. Light travels in straight line with very high speed, and in different media light has different velocity. When corpuscles enter eye, we get sensation, and colors are due to different sizes of corpuscles. Okay. So which phenomenons could this theory explain? This theory could explain reflection, refraction, and inverse square law, but this theory could not explain partial reflection, partial refraction, interference, diffraction, polarization. Another major drawback is it proposed that velocity of light in denser medium is greater than velocity in rarer medium, but actually velocity in rarer is greater than velocity in denser. Then another drawback is mass of the source should decrease because particles are emitting out of the source. Therefore, mass of the source decreases, but actually mass of the source is constant. Then these two theories are in board book, but in NCERT book these two theories are not there. Then in 1637, Descartes proposed corpuscular theory, and Newton developed it afterwards. In 1678, after some 30-40 years, Huygens developed wave theory of light. He said light is made up of waves. Light is not made up of particles. He said light is made up of waves. He considered each light wave to be longitudinal. He said colors of different lights are due to different wavelengths, and we get sensation when these waves enter into the eye. Medium is necessary. He said medium is necessary for propagation of light. And he said luminiferous ether exists everywhere. Luminiferous ether exists everywhere and light travels through it. This material has zero density and perfect transparency. This theory was not accepted because of the authority of Newton in that era, and Newton had proposed corpuscular theory of light. But in 1801, when Young performed Young's double slit experiment and showed that light produces interference pattern, at that time it was found that light is actually made up of waves and light is not made up of particles. Then successes of wave theory. It could explain reflection, refraction, interference, diffraction, and velocity in denser is less than velocity in rarer. Drawbacks of wave theory of light. It could not explain rectilinear propagation of light. Straight line propagation of light it could not explain. Then polarization. Compton effect. Compton effect means X-ray production effect. Then photoelectric effect. Michelson and Morley discovered that ether, luminiferous ether, does not exist. Wavefront and wave normal. Wavefront is what? It is locus of all the points of the medium to which waves reach simultaneously, so that all points are in the same phase. This is the point source of light. If and some waves are coming out of it, these all these wave reach this surface of sphere at the same time. Therefore each wave reaching the surface is in same phase. Therefore this spherical surface is called wavefront. Point source produces spherical wavefront, cylindrical source produces cylindrical wavefront, and point source which is at infinity produces plane wavefront. Then wave normal is perpendicular to wavefront. Wave normal is perpendicular to wavefront and in the direction of propagation of light. This is the wavefront. This arrow is the wave normal. Wave normal is what? Perpendicular to wavefront, perpendicular to this surface and in the direction of propagation of light. If we pass plane wavefront through prism, then it gets tilted. If we pass plane wavefront through lens, then it becomes spherical. If we incident plane wavefront on the spherical mirror, then also it becomes spherical. Construction of plane and spherical wavefront. These are the principles which are used for construction of new wavefront. Every point on the wavefront acts as secondary source. Every point on the wavefront acts as secondary source. So this is original wavefront. Each point acts as secondary source. We have considered only 3 points. These points start emitting new waves in all the direction. This sphere is new wavefront. This sphere and this sphere, these are new wavefronts. And new wavefronts are only effective in forward direction. In backward direction they are not effective. Then resultant wavefront, new wavefront, resultant wavefront. This is new wavefront and this is old wavefront. Resultant wavefront is tangent to all secondary wavefronts. Resultant new wavefront is tangent to all secondary wavefronts. This is the construction of plane wavefront. Huygens proved reflection at a plane surface by using his principles. He proved that I is equal to R, angle of incidence is equal to angle of reflection. Then Huygens also proved refraction of plane wavefront at plane surface. He proved this law. This is called Snell's law. He proved this law and also proved that velocity of light in a rarer medium is more than velocity in denser medium. Polarization of light. Polarization of only transverse wave happens. Polarization of only transverse waves happen. Then this is the source of light, this is first slit and this is second slit. When light is emitted from source, vibration of light is present in all the direction. So there are some particles which are vertically vibrating, there are some particles which are horizontally vibrating, there are also some particles which are vibrating at some angle. But when we pass these rays through this slit, then only vertical vibrations remain. And this slit also allows only vertical vibrations. Therefore here as well we get vertical vibrations. Then in second situation, here vibrations are present in all the direction. If I am saying vibrations, I mean electrical vibrations, not magnetic vibrations. Here vibrations are present in all the directions. Here vibrations are only in vertical direction, and this slit allows vibrations in horizontal direction. Therefore, after this slit there are no vibrations, no light is present. So when unpolarized light, this is the way in which unpolarized light is shown. When unpolarized light is passed through polarizer, light becomes polarizer. This is the transmission axis. This polarizer allows only light which is vibrating in vertical plane. Here vibrations are present in all the direction. Here vibrations are only present in vertical direction. So when unpolarized light becomes polarized, intensity always becomes half. If this intensity is I, then this intensity is I by 2, and that intensity is irrespective of angle of transmission axis. Angle of transmission axis is immaterial. If unpolarized light intensity is I, then polarized light intensity is I by 2. Then if this intensity is I, if this intensity is I, then this intensity is also I, because here all vibrations are vertical and this crystal allows only vertical vibrations to pass. So here intensity is I by 2, then this intensity is also I by 2. If this intensity is I, then this intensity is also I. Okay. Then if I rotate this crystal, then intensity at this point decreases, becomes 0 when this crystal becomes horizontal. Intensity again increases and becomes full when this crystal becomes upside down. As I rotate again at 270 degree, this crystal becomes horizontal and intensity again becomes 0. And at 360 degree, this crystal regains its position and intensity again becomes full. So for full rotation we get 2 maximas here and 2 minimas here. Then from polarized light we want polarized light. Listen carefully. From polarized light we want polarized light. If this intensity is I, then this intensity is I cos square theta. If this intensity is I, then this intensity is I cos square theta. This is Malu's law. And theta is angle between plane of vibration and transmission axis. It is angle between plane of vibration and transmission axis. What is the plane of vibration? Plane in which vibrations are present is called plane of vibration, and plane in which there are no vibrations and which is perpendicular to plane of vibration is called plane of polarization. Methods of producing plane polarized light. First one is by reflection. When light gets reflected light is partially polarized, and refracted light is also partially polarized, but at a particular angle. Polarizing angle theta p, reflected light is completely polarized. That is called plane polarized light, and refracted light is partially polarized. And at polarizing angle, reflected ray and refracted ray are at 90 degree to each other. And Brewster has given relation for polarizing angle, that is tan of theta p is equal to mu. Tan of theta p is equal to mu of 2 with respect to 1. This is 1 and this is 2, material number 2. Then dichroism. What is the dichroism? Dichroism means absorption. Selective absorption is called dichroism. Selective absorption is shown by tourmaline crystal. It absorbs light with vibrations perpendicular to a specific direction, and it allows vibrations parallel to transmission axis to pass. Then double refraction. Incident light is unpolarized. It has vibrations in vertical as well as horizontal direction. So extraordinary ray passes undeviated. It does not follow Snell's law. An ordinary ray follows Snell's law, therefore it gets deviated. So this is separation of extraordinary ray and ordinary ray. Both rays are polarized, plane polarized. It is shown by calcite crystal. Then in Nichols prism, calcite crystal is used, but calcite crystal is cut like this, and in between these two prisms, Canada balsam layer is put, that is transparent layer. Extraordinary ray passes undeviated, and ordinary ray gets deviated, and it gets total internal reflection. It gets internally reflected at Canada balsam layer, and after reflection it is absorbed at the black surface. This surface is blackened, so we get only vibrations in one plane. Then scattering also produces plane polarized light. If light is incident on a particle, then light is scattered in all the direction. Scattered rays in perpendicular direction are plane polarized. Scattered rays in the perpendicular direction are plane polarized, and all other rays are not polarized. This was discovered by C.V. Raman in 1920, and in 1930 he got Nobel for that. Then uses of Polaroid. Polaroid shows dichroism. To remove headlight glare, for 3D movie cams, for photographic cams, for windows of planes, for sunglasses, and for LCD screens, Polaroids are used. Then Doppler effect of light. Doppler effect of light is symmetric, whereas Doppler effect of sound is not symmetric. Frequency is different if source is moving, and frequency is different if observer is moving. It is independent of relative velocity. If source is moving towards the observer with 30 meter per second, or if observer is moving towards the source with 30 meter per second, apparent frequency is same in case of light, but not in case of sound. Therefore sound Doppler effect is not symmetric, but in light Doppler effect is symmetric. This is the accurate formula for Doppler effect of light. This is the approximate formula, but we will use this one. This formula is delta nu upon nu is equal to delta lambda upon lambda is equal to VR upon C. VR is relative velocity, C is velocity of light. And if reflected light is coming, and if there is reflection of light, then we will use this formula. For both these formulae, velocity relative should be too much less than C. Then red shift means frequency decreases, blue shift means frequency increases. If observer and source, if they are moving towards each other, then frequency increases. This is called blue shift. If they are moving away from each other, then apparent frequency decreases. This is called red shift. Applications of Doppler effect. Doppler effect is used to find out velocity of galaxies, to find out velocity of rotation of sun, and to find out temperature of plasma. These applications are not in NCERT.